A pleasant morning, sir, as well as to all the ladies and gentlemen that are actually here with us. Thank you for actually lending us a piece of your precious time as we discuss to you the assigned topic that was given to us. Well, for now, I would likely to take this opportunity to ask for your attention as well as lending us both of your ears as we, my fellow groupmates, discuss to you the 16th module which was entitled The Inverse Trigonometric Functions.
But before we get into our primary topic for today, let us first go over and review the stated objectives that you are expected to achieve and attain by the end of this discussion. After going through this discussion, you are expected to find the exact value of an inverse trigonometric expression, evaluate an inverse trigonometric expressions, and solve situational equation.
Thank you, Ryan, for that quick overview of our goals, or as how you commonly call it, our objectives. For now, let us formally get down to our very main discussion of the day.
As we all know, before we'd actually have the inverse trigonometric functions, there were only what we call the trigonometric functions, and that's how we commonly define it. Trigonometric functions are functions that are real functions which relate an angle of a right-angled triangle to ratios of those side lengths. They are actually used in wide range in all aspects of sciences that are related to geometry, such as navigation, solid mechanics, celestial mechanics, geodesy, and so on. However, if there is what we call trigonometric functions, then there also exists the inverse, which we call inverse trigonometric functions.
In calculus, inverse trigonometric functions is usually defined as the inverse function of the basic trigonometric functions, which are the sine, cosine, tangent, cotangent, secant, and cosecant functions. These inverse trigonometric functions is actually considered as an important concept taken in trigonometry, for it has major applications, especially and particularly on the field engineering, physics, architecture, geometry, navigation, and many more. Inverse trigonometric functions is famously known for its very useful role in finding the unknown measure of an angle of a right triangle when two side lengths are known.
So, basically in figure 1, it is already understood that inverse trigonometric functions is usually used in finding the angle of elevation if the horizontal distance as well as the height of the building is known. Now that we all know the important details in both of the trigonometric functions and inverse trigonometric functions, let us now proceed to its terms, symbols, and expressions of the inverse trigonometric functions. These are the terms and symbols. Sine inverse x is read as sine inverse or inverse of sine. This can also be written as arc sine. Cosine inverse x is read as cosine inverse or inverse of cosine. This can also be written as arc cos. Tangent inverse x is read as tangent inverse or inverse of tangent. This can also be written as arc tan. Now that we know its given terms and symbols, let us focus now on turning a trigonometric functions into its inverse. Trigonometric functions and the inverse trigonometric functions. Sine x equals y and the inverse trigonometric functions. Sine inverse the quantity of y equals x or arc sine y equals x. Trigonometric functions. Sine x equals 1 over 2. The inverse trigonometric functions. Sine inverse the quantity of y over 2 equals x or arc sine the quantity of 1 over 2 equals x. Trigonometric functions. Cosine the quantity of 5 pi over 6 equals x. The inverse trigonometric functions. Cosine inverse x equals the quantity of 5 pi over 6 or arc sine x equals the quantity of 5 pi over 6. Trigonometric functions. tangent x equals the quantity of negative square root of 3, the inverse trigonometric functions, tangent inverse the quantity of negative square root of 3 equals x, or arctan the quantity of negative square root of 3 equals x.
Now that we know how to turn a trigonometric function into its inverse, we will now move on finding the exact value of an inverse trigonometric functions and how we will do it step by step. Now the first item we have here is the inverse of sine 1/2. And in order to find here the value of x, get first your scientific calculator and simply type shift, sine, and the quantity of 1/2. And the answer would be 30 degree, or in radians, the answer would be pi over 6. If you're still not satisfied and you still want to ensure the accuracy of your answer, set first your calculator into radian mode. And if you don't know how to change and set your scientific calculator, just simply type shift, mode setup, then choose the option radian mode. Now that your calculator is settled, let us try reversing the process. And say for example, we are finding the value of 1/2. If you are to find the value of 1/2, just type sine and 30 degree, and the answer should be 1/2. Therefore, if you get 1/2 as your answer, then this only means that your answer in this item is undeniably correct. And if you're doing this only means that you're actually finding the measure of the angle when you take the inverse of a value. And this happens when you reverse the process and find the value of 30 degree. Moving on to the second item, now in item number 2, here we are to find the inverse of tangent negative square root of 3. Well, here, there isn't actually a big difference on example number 2 from the given equation in example number 1. But let us answer it anyway. So to get the inverse of tangent negative square root of 3, type shift, tangent, then close parenthesis and insert the equation negative square root of 3. And then your answer would be negative pi over 3. Then that makes it x is equals to negative pi over 3. Next, we have item number 3. Arc cosine times the quantity of cosine 3 pi over 4. Do you remember the process wherein you should evaluate first what is inside the parenthesis? Well, that goes for this example as well. Evaluate first what is inside the parenthesis. So, first we need to find the value of this cosine 3 pi over 4. And that would finally bring us to the answer of negative square root 2 over 2. And now that you already got the value of the equation inside the parenthesis, we can now evaluate the whole equation. By the way, if you're a little bit confused, this arc cos is the same as cosine inverse, okay? So now let us continue. Evaluate all the equation by typing shift, cosine, then the equation, and click the equal button, and you'll get 3 pi over 4 as your final answer. I'm sure you already know how to derive the next example, which is item number 4. Nevertheless, let us still give it a shot on answering it for it to be clear for all of us. So, as what we did on item number 3, let us first evaluate what is inside the parenthesis. So, first would be arc cosine times the quantity of square root 2 over 2, then hit the equal button and your answer would be pi over 4. After that, you can now derive the whole equation. So that makes us move to the second step. And that would be tangent times the quantity of pi over 4, and your answer would be a whole number 1. Was that clear? Now if it's clear, let us now move on to the last example, which would be the example number 5. Inverse of cotangent square root of 3 over 3. Now, if you're a little bit of confused of what inverse of cotangent is, inverse of cotangent square root of 3 over 3 is actually the same as inverse of tangent square root of 3 over 3. So technically, you can just type inverse of tangent square root of 3 over 3 and your final answer would be pi over 3.
Now that we know how to find the exact value of an inverse trigonometric expression, let us now move on evaluating an inverse trigonometric expression. Now in item number 1, we are given a task to simplify a certain equation, And in this given item, before we attempt to simplify all the equation, let us first solve cosine inverse of 1 over 2. So we all know that cosine inverse of 1 over 2 is equivalent to pi over 3. So therefore, we have now sine times the quantity of sine inverse of 2 over 3 plus pi over 3. Now that we have an almost complete equation, let us now derive the equation using the sine sum identity. Sine times theta plus null set equals sine theta and cosine null set. After deriving it, let us now solve the equation sine times the quantity of sine inverse of 2 over 3 and cosine pi over 3 plus cosine times the quantity of sine inverse of 2 over 3 and sine pi over 3. Copy first 2 over 3, then find the value of cosine pi over 3. Cosine pi over 3 is 1 over 2. So after you get the value of cosine pi over 3, which is 1 over 2, copy now the remaining equation, which was the cosine times the quantity of sine inverse of 2 over 3 and sine pi over 3. So all in all, we now have 2 over 3 times 1 over 2 plus cosine times the quantity of sine inverse of 2 over 3 and sine pi over 3. After that, multiply first the 2 over 3 and 1 over 2. And we will now get 1 over 3 as our answer. Then copy again the remaining equation, cosine times the quantity of sine inverse of 2 over 3. Next is try finding the value of sine pi over 3, and that makes it square root of 3 over 2. Now we have 1 over 3 plus cosine times the quantity of sine inverse 2 over 3 and square root of 3 over 2. Now try moving the square root of 3 over 2 into the right side beside the 1 over 3, and we will have 1 over 3 plus the square root of 3 over 2 cosine times the quantity of sine inverse of 2 over 3. Let us now move on to the next page. Now this is a little bit confusing, so I would likely advise you guys to listen carefully. So getting the quantity of sine inverse of 2 over 3 means that sine theta equals 2 over 3. Using the Pythagorean identity, 1 equals sine squared theta plus cosine squared theta. We will now follow this formula, and that brings us to cosine theta equals the square root of 1 minus sine squared theta. First step is to substitute the values, and we will now have the square root of 1 minus 2 over 3 squared. Derive this equation, and that is how you get the square root of 5 over 3. Now going back to 1 over 3 plus the square root of 3 over 2 cosine times the quantity of 2 over 3. Now that we got the value of cosine times the quantity of sine inverse of 2 over 3, which is the square root of 5 over 3. We will now just multiply the square root of 3 over 2 and the square root of 5 over 3. So the square root of 3 over 2 times the square root of 5 over 3 is equivalent to the square root of 15 over 6. And now we have 1 over 3 plus the square root of 15 over 6. Using your scientific calculator, the accurate one perhaps solve 1 over 3 plus the square root of 15 over 6. And you will get 2 plus the square root of 15 equal over 6 as your final answer.
And now, let's proceed to example number 2. Simplify sine 2 cosine inverse the quantity of negative 4 over 5, getting cosine inverse the quantity of negative 4 over 5. This means that cosine theta equals negative 4 over 5. Using Pythagorean identity, we have sine theta equals the square root of 1 minus cosine squared theta. We just have to substitute the given, and we'll get the square root of 1 minus the quantity of negative 4 over 5 squared. Using your scientific calculator, simplify it and the answer will be equal to 3 over 5. Using sine double angle identity, we have sine 2 cosine inverse the quantity of negative 4 over 5 equals sine 2 theta equals 2 sine theta cosine theta. Just like what we did in the first part, we will only substitute it again. Using your scientific calculator, simplify it and we will get the final answer, which is negative 24 over 25.
You are an architecture student in a prestigious school. You are tasked to illustrate in detail the following situation with all the dimensions needed, not necessarily in scale. One dimension, though, is missing in the situation, the angle of depression. To be able to know one of the needed dimensions, you should solve for the missing angle in the given problem. A lighthouse at sea level is 34 miles from a boat. It is known that the top of the lighthouse is 42 by 5 miles from the boat and that x is equals to r cos theta, where x is the horizontal distance, r is the distance of the top of the lighthouse from the boat, and theta is the angle of depression from the top of a lighthouse. Find theta. As you can see, before we solve this problem, we made an illustration for easy understanding purposes. Based on the given data, x is the horizontal distance, r is the distance of the top of the lighthouse from the boat, and we have to find the angle of depression, which is represented by theta. To start, we have to fix the x is equals to r cos theta. Since we are looking for the theta, the formula will be cosine theta is equals to x over r. Then, the next step is to substitute the given data. After substituting, we just need to divide 34 and 42.5 in order to get the 4 over 5. Finally, using your scientific calculator, simplify cosine inverse of 4 over 5. We get 0.6435 in radian and 36.87 in degree mode. So technically, the angle of depression from the top of the lighthouse is 36.87 degrees. That's all for today. Thank you for listening and have a great day.